Hey guys, welcome to my 6th and last video on the molecules and matter topic. Today we're going to be looking at gas pressure. So I have talked a little bit about gas pressure before, but today we're going to be going over it in depth. So what is the gas pressure? Well, the gas pressure is the amount of collisions of gas particles in a container. So if there are more collisions of gas particles in the container on the walls, then the gas pressure will be higher. Now, some factors that can increase the gas pressure are the size of the container, the temperature of the gas, and last of all, there is the amount of the gas inside. So let's have a look at some of these in some more detail. So the reason the size of the container will have an effect on the gas pressure is because gases will fill the container that they are in. This means that if you have a smaller container, the gas will be less able to spread about, so all the particles will be close together. This means that they'll bounce off each other more often and bounce off the walls more often, because gas particles are constantly moving around and they want to expand, but they've not got the room, so they will bump into the sides of the container and other particles much more if this container is smaller. The temperature of the gas has an effect because increasing the temperature of the gas will mean that the particles are moving around more, which will cause more collisions with each other and the sides of the container, which will increase the gas pressure. And the amount of gas in there as well will have an effect, because even if it's a really big container, if you put tons and tons and tons of gas in there, then there are still there's a high concentration of gas particles, and this means there'll be much more collisions than if you put say a small amount of gas in. There'd be much less collisions then. Okay, so now how do we know how the gas particles behave? It's all very well saying this is what they'll do, but how do we know that how they move like that? Well, there are actually two methods that we use to discover the movement of gas particles. The first one is called Brownian Motion. Now, it was originally discovered using pollen grains. However, we can reproduce it much more accurately by using two things. The first is being wax, that I'll explain, or fat, and the second is smoke, which is slightly different, but it's still a similar principle. So the reason we can predict it with fat and wax is because we put a droplet of wax under the microscope, and we can look at it under the microscope, and it appears to be wobbling. Now, the reason for this is because as the fat is there and it's in the air, there are air particles constantly moving around, and they are hitting the wax, and this causes it to vibrate or wobble around. And so that's how we know what the gas particles in the air are doing, because we can observe the fat particles, watch how they behave, and then imagine that and respond to the effects of the air. Now, the second one is by using smoke. So what we do is we light a splint and put some smoke into a sealed container. Now, the smoke particles, we can look under a microscope and see that the smoke particles will almost twinkle if we look at them like the stars in the sky. And this is because the collisions of the air particles that are already in the container will bump into the smoke and cause it to move around, and this is what causes the twinkling that we see. It's the smoke moving around because of the collisions. So that's all for this video. I hope it was of great help to you, and that is it for the molecules and matter topic. If you enjoyed this and want to see more revision videos in the future, please be sure to subscribe, leave a like and comment in the comment section below. That's all for now. Bye.